All right, broski, it's T and I'm back with another video, man. It's on a channel called the Movement System. He's got 81K subscribers, yeah. So let's see how muscles build, because he says muscle versus tendon growth. Well, let's review this video and see what he says, because I'm curious what all these other people, if they're going to bring out proof or what they're going to say here.
Hey, what's up guys, I'm Matt with the Movement System. In this video, we're going to explain how muscles...
Right off the bat, he's got a chart here. He wrote a chart, just says muscle hypertrophy in it. But he hasn't really brought up any scientific proof, even though he's using science. He wrote this out himself. But let's see what he says.
grow versus how tendons grow. Let's go ahead and dive into it. Okay, so let's go ahead and start off with learning about how muscles grow. So a lot of us have been to the gym and done resistance training and seen our muscles get bigger. But what physiological...
Let me get this straight. People go to the gym, they do resistance training, and they see their muscles get bigger. They do? I don't really see anybody getting any bigger in there. I don't know. Okay.
Logically is causing that muscle growth. How does it work? Well, we know there are three primary variables: mechanical tension, metabolic stress, and muscle damage that...
So mechanical tension, metabolic stress. So you want to stress muscles with metabolic stress. You want to cause it to stress. Okay, that's going to build a muscle. Muscle damage is going to build a muscle. None of these things build muscles. They do something specific to the muscle, but they themselves do not build a muscle. Yeah, so that for sure he's got wrong.
All contribute. More recently, it seems like mechanical tension is the primary driver.
They all contribute to cause some sort of a damage to the muscle fiber. What that damage is, it will give you a response. Now, similarly, they all give the same response. They give an inflammatory response. See what I mean? But he's not very specific on the last one, the muscle damage. He just says muscle damage. What type of muscle damage? I don't know. But again, metabolic stress could be a type of damage. A stress can cause a damage. And oxidative stress can cause damage to the myofiber as well. Does that mean it's going to grow as well? Well, it's a damage. Get it? Mechanical tension can cause some damage. What type of damage is mechanical tension causing? See what I mean? An inflammatory response, some buildup of chemicals. Now, metabolic stress, it does the same thing. And then you have muscle damage. Muscle damage, that's quite different, yes. He says here, see that on the list there, it says micro trauma down there on that graph? Well, a micro trauma is a micro injury. Okay.
Of muscle growth. Now, this physiological process is a little bit oversimplified, but we're going to try to hit the big picture here. Our muscles have satellite cells in them. These cells are basically like stem cells. They haven't yet built the characteristics of skin or tissue or tendon or muscle. They haven't decided yet what they're going to be. So we need to do something to activate.
Yeah, they activate, differentiate, they proliferate, and then differentiate. Split, divide, and increase in number. Yeah, definitely. They can do that under something very specific. What he wrote here, it says microtrauma. You have to cause microtrauma, not mechanical tension, not metabolic stress, and not this muscle damage stuff. Maybe this is like deterioration. This muscle damage, he means deteriorate the muscles and then they'll build. I don't know what he's talking about. The microtrauma one is in the list here. That one's the one that actually causes it to activate. But okay. But again, none of these things will matter if protein synthesis does not exceed that breakdown. That muscle ain't never gonna grow. And another problem is the microtrauma. It doesn't happen all the time. See what I mean? It has to be under very specific conditions for that muscle to receive a microtrauma. You understand me? So that satellite cell can donate its nuclei to that domain to further that myonuclear domain size limit, because that domain had reached a ceiling limit during hypertrophic process where the satellite cell is beyond where it can donate any extra nuclei to that domain to support further muscle growth. So what do you have to do to get it to give more of this? Well, you got to make it cause, and you have to get it you have to cause a microtrauma to it. How do you do that? Not with a hammer. You understand me? And definitely not going chronically to the gym or lifting. A lifting can cause it, but it's under very specific conditions. That's all I can tell you.
These satellite cells and cause them to turn into muscle cells. So what we do is
They turn into muscle cells. Well, yeah, they do definitely turn into muscle cells, and they donate their nuclei, and the nuclei, they synthesize protein. Without them, you can't further that domain without them. They synthesize protein, so no matter how much protein you do eat, without them, you won't grow any muscle.
Resistance training with mechanical tension, meaning tension on the muscles. We also involve metabolic stress, meaning that pump that you get.
Metabolic stress, that pump you get, that pump, it would be glycogen. So that is not part of your diet as a human. You're a carnivore, so you eat a carnivore diet. Really, that's really your natural diet. But if you're eating a herbivore diet, a cow diet, eating grass, trying to convert this sugar into glycogen, pumping it in your body and stuff. Look, man, grass will not, you can't build muscle out of grass, but cows can. But you're going to eat this and you're going to just draw glycogen in the muscle. That is a secondary shift into sarcoplasmic hypertrophy. When this domain ends, when it reaches a ceiling limit during hypertrophic process, there is a secondary shift into sarcoplasmic hypertrophy where it starts loading the glycogen into the muscle, creating artificial muscle growth. That's what it does, okay? When you can't get these micro traumas anymore, because the micro trauma is protected by the repeated bout effect phenomena. It protects muscle from being damaged with a repeated bout. That's what it does. So there's no more micro trauma, and it reached a domain limit. MND size reached a domain limit. And there you go.
In the gym, as well as some amount of muscle damage. All three of these work together to cause some sort of micro trauma at the cellular level.
Yeah, I'd say they do. They all kind of work together synergistically if you know how to do that. So he's now telling you they don't build muscle, they cause micro traumas. First he told you they build muscle. Now he's telling you they cause micro traumas. Which one is it? This guy hasn't made up his mind yet.
This doesn't mean we're ripping our muscles apart, but at the very small cellular level, there's some damage to the Z discs and to the myosin and to
And what does that feel like? What's the feeling afterward when you get this so-called micro trauma, the Z discs, this whatever you're causing to it? What would be the physical feeling of this? Would you feel pain? Soreness? What would you feel if you got that, sir? Could you please explain to us?
Other parts of the muscle fiber.
Yes, what are we looking for exactly? What is the physiological feeling in the reality, in the real world, in the real world? What do we need to look for to know that we actually caused it to get a micro trauma and not nothing at all? You understand me?
That then therefore need to be repaired. So at the very microscopic level, we have micro trauma.
You just go and do these things, and then it causes a micro trauma just like that. And then what? And then that's it. There's nothing there. Like, how does it cause a micro trauma if it's protected by the repeated bout effect phenomena? How do you get over that? See what I mean? And it's reached a ceiling limit during hypertrophic process. This satellite cell ain't donating any more nuclei to that domain to support any more growth. So what are you talking about?
From resistance training that causes a hormonal cascade of satellite cell activation.
Yeah, this is all cute. A cascade of hormonal this, that, yes. But what do you need to do to cause that muscle to get a micro tear? You have to do mechanical tension, metabolic stress, and muscle damage. Okay. You just do that. You just go to the gym and it just does it automatically for you. Okay.
This means that after training, your hormones like testosterone and growth hormone and insulin-like growth factor all work together to act.
I understand. So you do all three of these things, and then you get that, number 4. So you do these 3 things. That's how you get over MND size limit, and that's how you bypass the repeated bout effect phenomena. Okay, yes, I get it now.
Activate these stem cells. So these stem cells were quiescent or quiet. They were in a non-active state. And then we did training. We caused a training stimulus and stress that activated them to actually initiate what we call muscle protein synthesis.
Oh, that's what it does. It activates protein synthesis Muscle protein synthesis. So we can just keep doing this. We should be massive already doing this every time we go to the gym, right? We're getting this micro trauma, and then we're getting this protein synthesis, satellite cell fusion, and all that, right? This muscle fiber. So why isn't anybody getting massive doing this?
Muscle protein synthesis is a growth response where we're taking these cells and we're kind of filling them into that area of damage.
Okay, so how much protein do you need then? You said there's a window now for protein synthesis. Here's a question I have for you. How much protein do you need now to actually build that muscle? If you've gotten this so-called micro trauma, how much does it take exactly?
They're taking on the characteristics of the muscle cells around them, and they're becoming new muscle. This is really fascinating to me and other exercise.
They're just taking on the muscle around them and making new muscles, just like that. Oh, cool.
Science people, because the protein that you eat in a muscle milk or a protein shake or a piece of steak literally turns into amino acids. And
really? Just that piece of steak or that shake or whatever, it turns into amino acids. Oh.
And those amino acids turn into the muscle that is on your...
And they turn into the muscle, but you didn't account for the breakdown, because if there's a protein synthesis, there's also a window for protein breakdown. So what if we just eat that steak and it just replaces the breakdown during that open window of protein synthesis? Oh, what happens then, sir? Like, you've never mentioned how much protein do we need to actually grow that muscle. You just say we ate steak, is just going to grow just like that magically? Just from a little steak or maybe a Cocoa Puffs or something? What about herbivore diet? What about glycogen and all that? Doesn't that build muscles too? Come on, bro.
Your body. So it kind of works full circle that way. So we cause that muscle protein synthesis response, and that causes nuclei at the DNA level to turn into amino acids, to turn into muscle proteins.
Oh, the nuclei are going to turn into all this, and then they're going to turn into what? Oh, muscles, yeah.
We're making your muscles bigger. Primarily, we're adding what's called sarcopenia.
See, guys, he just gave you the secret, and they're going to make your muscles bigger. So all you have to do is eat a piece of steak, cause these microtraumas, get this satellite cell, boom. You just have to train metabolic tension, metabolic stress, and get some, and you have to train for muscle damage, metabolic stress, and mechanical tension, and then you get this microtrauma, boom, and then there's a signal. It signals here the satellite cell activation, and then you get this signaling, the hormonal signaling, boom. Protein synthesis is open. These nuclei, boom, come here. You eat this piece of steak or a shake or something, and it will turn into muscle. And you can fucking do this all the time, and you're gonna get fucking massive, bro, like Ronnie Coleman. Yeah.
In parallel, increasing the cross-sectional area or the thickness of your biceps.
Holy shit, the thickness and in parallel. Damn, bro, see that? That's not hyperplasia, that's hyperplasia.
So overall, if we keep this cycle going over and over again, you're going to keep activating these satellite cells. Your body will replenish those satellite cells as you eat protein and break it down into amino acids. Then you're going to cause more micro trauma to that muscle. You're going to repair that micro trauma through hormonal cascade and muscle protein synthesis, and your muscle will get bigger and bigger. That is how we build.
See, guys, that's how you build muscles, guy. That's it. He's got the formula right there. And you just keep doing this again and again. Eat that piece of steak and think that thing and do these training modalities, and boom, micro trauma, and you're gonna get muscles, bam. It's gonna donate it to satellite cell and all that. And you are gonna grow a muscle, broski. This is the magic formula that we've all been looking for. Yes. Have any of you tried this yet? You gotta go out and try it, man. You're gonna be building muscle. You're gonna be building muscle 24/7 while you fucking work out and sleep at the same time.
Muscle, but how do we actually build tendon? All right, so the way we build tendon.
Oh, he's gonna tell us how to build tendons. Oh, the blood doesn't flow to them very well. They don't have any blood vessels in them, do they?
Is collagen synthesis. So very similar to muscle protein.
Oh, collagen synthesis. Oh, based on protein synthesis. But isn't there collagen in protein, animal protein? Oh, come on, man.
Protein synthesis, but collagen is for our connective tissue. tissue. So we have our muscle labeled here in red, and then we have gray here as our tendon or our connective tissue. In reality, our connective tissue actually goes through our muscle fibers as well. We actually have fascia running on the outside of the muscle and even in between the individual fibers. But primarily when we're thinking about building tendon, we're thinking about that connection from the muscle to the bone, or that primary tendon. Tendons in our body are things like our Achilles tendon or our bicep tendon or our patellar tendon. And a lot of times we want to build strength of those tendons so we don't have irritation and pain and discomfort with jumping and running and training. So how do we actually do that? Well, we can introduce a training response, specifically isometrics and heavy slow resistance exercises target the tendon. Now, why do we need isometrics and heavy slow resistance exercises?
Wow, they target the tendons, and it says there it causes a micro tear. Oh, micro trauma.
Why aren't just normal, regular repetitions of about 5 or 6 reps? It's probably not enough load to really meaningfully drive tendon changes with...
Okay, it says there isometric and heavy load resistance. Heavy flow resistance. That's it. That's all you have to do. And boom, you get this micro trauma, hormonal signaling, IGF-1, growth hormone, bang, collagen synthesis, and that's it. And you get these tendons, yeah.
Really strong contraction forces.
Yeah.
That's why we're often using isometrics, because as long as both of them are heavy enough and delivering enough load to the tendons. Okay, so let's look at the whole process though. Assuming we're at the tendon.
But wouldn't that happen even though you were doing the muscle stuff, building the muscles? This would automatically happen, wouldn't it, bro? Getting trauma there, it must be getting trauma here, no?
This is a good thing because it's actually going to cause a hormonal signaling cascade.
How long does this thing take to repair this micro trauma? How many days? 24 hours? Couple of weeks? 1 day? Few hours? 1 hour? While I sleep at night? Autophagy? What? Does it work on a starvation diet? I mean intermittent fasting, sorry. Yeah, man, I don't know. Like, how long does this take to build this muscle? You never even said in these these tendons. How long does it take? There's no mention of it anywhere. This is unfortunate.
In this case, that hormonal signaling is driven by growth hormone and...
Wouldn't you be weak if you caused micro trauma to this shit and your muscles and these tendons and ligaments? Wouldn't you be fucking weak now? You'd be susceptible to a real massive injury if you were to do something, eh? Without them being fully repaired. Damn.
IGF-1, not quite. We're getting a good hormonal response. We're in range of repetitions, meaning you can do sets of 5, you can do sets of 10, sets of 20, and as long as you're pushing your muscles hard, relatively close.
Yeah, I just, as long as you don't tell me that that's going to build me a muscle, those weights, okay?
To failure, you can achieve good muscle hypertrophy, but when it comes to tendon, load is really important, and we want to get close.
Load is important, bro. I'm going to leave it at that. Tell me what you think about that. Like, subscribe, support the channel. I just think this is insane, bro. But whatever. The movement system, building muscle, and tendon strength. Okay, whatever, man.